Hello, everyone. Welcome to Rational Science. I thought for a moment I was cut off. Welcome to Rational Science, directly from Frankfurt, Germany, and the only site on the internet that does science. Everybody else does particles. And you cannot explain a single phenomenon of nature, invisible and intangible phenomenon of nature, with particles in a rational manner. And science is about rationality, rational explanations. So yeah, this is the only site that does science. And today we're going to talk about an uninvited guest, and his name is God. But he's not the God of the Bible. He's the God of quantum mechanics. He's the God of really of mathematical physics, specifically of quantum mechanics. And the other day we covered God, the God of Christianity primarily, and we found out that he's there, right? I mean. Religion claims that God is eternal, that he had no maker. And I really have no problem with that. I can accept that hypothesis. The problem I have with God, with eternal God, is not him. It's how he created something from nothing. How he created matter from total void, total nothingness, from space, from vacuum. That's I can't find the spec or the instructions or the process in the Bible. That's the problem I have with the notion of an eternal God. How he created the first bit of matter. And quantum mechanics, together with general relativity and the rest of mathematical physics, has a similar problem because they get rid of God altogether. But they do believe and propose and spread that matter came into existence. I guess you can call it from nothing, whatever nothing is, because when you put them, you put the mathematicians against the ropes and begin to pummel them, and you say, well, where did the first bit of matter come into existence? They say it's an unscientific question, and they put it off like that. They say it's like asking what's north of the North Pole or who knows what. And the reason they say that is that, or the way they justify it, is by saying they have no way of testing that hypothesis. Okay, so in either case, we have to concede or grant as a starting point, not from frame one, but for frame two. Frame one, in one case, we already have God. In the other one, we have something, call it whatever you want, and from that point on, we have the Big Bang explosion and everything that we see today. So what we're going to look at today is that process, how this God of quantum mechanics grew into adulthood. I think he's a teenager today because, I would think that God has, the God of mathematics, right, has a long life ahead of him. I would say maybe trillions of years. Assuming that's the case, well, he's in his infancy now, okay? And today we're going to look at the process, not of how he began, because, they concede that. They say he already started or he was there or whatever. And we're going to look at how he grew up, okay? And so let's look at these two gods, the one from Christianity, compare them against the one from mathematical physics, and see if there are any differences and what those differences are, if any. Okay, here it is. Okay, the God of the Bible says, in the beginning God created the heaven and the earth. Okay, so he was already around. Okay, and the earth was without form and void, and darkness was upon the face of the deep. Okay, and in the case of quantum, the quantum Bible, the ancient quantum Bible that is at least or close to 100 years old, it says, in the beginning there was nothing. okay? And we're going to try to find out what this nothing is. Part of it has to do with that. But they say that there was no God in a Christian sense or in the Old Testament sense, that there was a God around to do any of this. So they get rid of God altogether. In fact, all these people claim that they are atheists, that they don't believe in the existence of God. And so they try to do what they call scientifically. Okay, so we're going to do this scientifically, okay? Okay, let's go to step number 2. We get the first frame of the movie, of the universal movie, and here's the 2 versions. In the case of Christianity, you read that, and the Spirit of God moved upon the face of the waters. Okay, so there were waters. We don't know where those came from. And God said, let there be light, and there was light. Okay, and God saw the light, that it was good, and God divided the light from the darkness. In other words, he created the day from the night, because in the day you have this sunny day. In other words, you have a sun, you have clouds, you have a blue sky, and at night it's like dark and little stars are out there, so it's a little different. Okay, so that's, I guess, what they're referring to. In the case of mathematical physics, we have the quantum foam. That's where it starts. Says, and the quantum foam moved upon the face of the false vacuum. Okay, and the equation said, let E equals mc squared. Then there was energy, and the mathematicians saw the energy, that it was scientific. Okay? And then they equated energy with space. That's essentially their version of creation in a nutshell. Okay. According to mathematical physics, space is a physical object made of particles. In other words, it's the ether, the same thing we've had for the last 3,000 years. Ether, bunch of particles. And the only issue there is whether all these bunch of particles are space. The word space refers to all these bunch of particles, or whether the particles are contained within a container called space. And those are 2 different notions of the ether. One is a bunch of particles, and you wonder what separates one particle from the other. You know how you can distinguish them unless there's something in between them. Okay? And that whole body forms space, vacuum, whatever you want to call it. The ether is space in that case. And in the other case, it's these particles that are within something called space, which is, I guess, some kind of container that has a border, a fence. And the only issue there also is, what's outside of the fence, what gives shape to that container called space. So all these things are the ones that these people have yet to justify and somehow rationalize for us. Okay, so this is where we're at. Okay, so what happens next? Well, let's look at one version here. This is the Christian version. It says, God is assumed to be eternal. That's fine, we'll concede that. God creates heaven and the earth. There we have a problem, because now he's creating something from nothing, and we don't know how he did that. Okay, but here's the issue. The issue, because this is where the difference is going to be with mathematical physics. Okay, so pay attention to this. It's the timing. Okay? The Bible, if you go by the Bible, literal reading of the Bible, no reason to interpret anything here. I'm sure God would not like us to be confused. Here's this supreme being. I think if he wrote the Bible, if he's the author, as is said out there, he would have written the Bible in such a way that everybody understands the same thing. And the way I look at it, if we're all confused and we cannot explain, and this guy interprets one thing, the other guy interprets something else, we have to think that it's the devil who's sticking his tail in there, right? Confusing people. That's my logic for that, okay? Anyways, here it is. What does God do on the first day? He creates light, okay? And separates night from day. Second day, he creates the firmament, the heaven, the sky. And what does he do that for? Apparently to separate the waters. Okay, the waters from the ocean, from the sky, I guess, okay? Third day, we have dry land for the first time. We can put our feet on something. Okay, we have dry land, seas, and he creates the plants. Okay, Fourth day, we have the sun, the moon, and the stars. He finally sprinkled all these little dots out there in the sky. Who knows for what reason? I guess for our enjoyment, so we would not see a dark sky all day long. And, you know, we would look up there and see all these little lights and say, oh, interesting, how nice. Okay. Fifth day, he creates the fishes and the birds. So we've got something inside the water, we have something in the air. Okay. And finally, he thinks about populating the earth. We have terrestrial animals and man. Okay, we finally came in there, and I guess we were the last ones to be created, you know, and you wonder why. And then seventh day, God rested, and my only issue there is, why did God need to rest? I mean, he's all powerful, and all he's got to do is say abracadabra, voila, you know, hocus pocus, whatever the magic incantation is, and you know, it would not even take a day. It would take 1 second, a split second, and whatever he creates, it's there. Now, if he took a full day, you would think there's some kind of process, some mechanism, some specification of how to do this, okay? It'd be nice, you know, it would have been nice if he would have written that down, you know, in the Bible, so we knew what the process was for creating these things. But again, if he did it by hocus pocus, magic, whatever, I don't know why he needed to rest. I think the only reason he would need to rest is if he's tired, and if he's tired, it's because it took him some kind of effort, physical effort, to create these things throughout the whole day. And yeah, again, it'd be nice to know what the process was. Okay, but we don't have that information. The Bible doesn't tell us. And that was a big omission, I think. Okay, okay, so how does quantum mechanics do it? Let's put it over here so we can compare it side by side. Okay, and you have this chronology, which I'm going to go over in a minute, but I want you to look at something. I want you to look at the timing. The timing is totally different. And unlike the one on the left, that goes day by day. In other words, it's constant. It uses a single unit, which is the 24-hour day, I would think, because I don't see why they would have to call it a day if it's not a day. And, you know, you would think that that's a full day, especially when he said, you know, separates night from day. He says that in there, or the Bible says that, God is telling us this. If he separated night from day, meaning a 24-hour human day, you would think each one of these took one human day. There's no reason to think that you have to interpret these days as millions of years or anything like that. On the other hand, on the right side, you see something very different. The first few phases took seconds, actually microseconds. Okay, took a very, very small amount of time. From there, they jumped to minutes. From there, they jumped to thousands of years, to millions of years, and to billions of years. So the chronology there is totally exponential. Okay? The one that quantum mechanics comes up with to explain the origin of the universe, right? Okay, so let me get back in here. Okay, the other thing I want you to see is this. These are the phases, the epochs for each one of the two eras. There's two eras. One is the radiation era and again, we're talking about right after the Big Bang, because we don't know what happened at that first frame, at frame number 1, where the Big Bang was getting ready to explode, okay? So we don't know what happened there, and they don't have an answer for that, and they say it's outside of the bounds of science, etc., etc. Okay, fine. So all we can do is look at from frame number 2 onwards, okay? And this is what you get. You get 2 stages, or epochs, or eras, periods, whatever you want to call them. One is the radiation era, and it consists of all these epochs. Planck, the grand unified, okay? Which is the grand unified theory, okay? Remember, they're trying to unite forces, okay? And that's what they're going to talk about there. Then they have the inflationary period, where this thing expands, apparently exponentially again. Electroweak, the quark, the hadron, pronounced differently in different parts of the world, which is when you get into the neutrons and protons, okay? And then suddenly you jumped into the leptons and the nuclear era. On the other side, you get, see this, the ones on the left are going to be in seconds and maybe you could call it even a minute. When you get on the right-hand side, the matter area, now you get into thousands, millions, and billions of years. And we get the atomic epoch, the galactic, and the stellar. Okay, so that's, in a nutshell, what they propose, okay, what the mathematicians propose. And here's a, I guess you could say, a quick synopsis of this so that you can see what I'm going to cover here and how they view this, okay? These are the different eras, okay, and the different epochs within each era. Okay, here's the matter era here, divided into atomic, galactic, and stellar epochs. And the first part, which is the radiation era, is separated by these Planck, the grand unification or unified, right? The inflationary period, which is the world expands exponentially. And then you go to these, the quarks, the hadron and lepton, and the nuclear. Okay, so that's essentially how mathematical physics sees the evolution of the universe. And again, I would have to suspect that Father Universe is not so much father, maybe he's a teenager by now, okay? So I don't know how mature he is. Okay. Okay, here's the first era, known as the Planck Era, which is microseconds. I mean, you're talking about, what is it, 10 to the minus 43, I think, seconds right after a Big Bang. So it's you don't even have time to measure because it's already gone. Okay, so that's how fast this was. It was just blip. It came and went. Okay, and here it is. Okay, and this is again the Planck Era, the Planck Epoch. Okay, and it says the Planck Epoch. What does it consist of? It's no matter existed, in the universe at this point in time. Okay. And only energy, whatever energy is. Again, they use this word energy as a substitute. I call it the word spirit because they claim there's no real matter, no particles, I guess you could say, because even if you have a single particle, you would think that's matter. But they say, no, all we have at this point in time are energy and the ancestor of the four forces. Okay, and no, they're not talking about the four horses of the apocalypse. They're talking about four forces of quantum mechanics. And we have a problem here, a real problem, because I can only imagine two forms of contact, and which we call forces. One is pull and one is push. That's it. And in fact, if you go into quantum, you find the two push forces. One is the photon, the electromagnetic force, and the other one is the weak force. Okay, and those are the push forces because they are outward going. They go out of the atom. And then you have the two pull forces. One is gravity, which they have never figured out, and the other one is the gluon, which holds, the quarks together inside the nucleus of the atom. So we have two push forces, two pull forces, but they claim they have four forces. So you figured it out, okay? So the issue is, right now we have no particles, matter. They have what? They have energy and they have forces. But it turns out when you go into quantum, they mediate all forces with particles. They say the forces are particles. Because what is the electromagnetic force? Well, that's the photon. It's a little ball, supposedly, that mediates light and electromagnetic phenomena such as magnetism. So you have a particle anyways. And what is the weak force? It's a particle. The W's and Z's are particles. What is the graviton? Well, it's the mediator of gravity, which is a force, but what is the mediator? The graviton. What is the gluon? Allegedly another particle that mediates the strong force. So they're all particles, and a particle is matter. But they're claiming there's no matter in this period, this era, or this epoch, the Planck epoch. All you have is forces. And what are forces? Particles. What are particles? Matter. So they have a circular argument, in other words. And why? Because they never defined their terms. They're suggesting that they're talking about particles, but when you say, well, are you talking about really particles like, little balls? No, we're talking about numbers. We're talking about quantities. We're talking about amounts and units and that kind of stuff. It's all math. It's got nothing at all to do with particles, meaning it's got nothing to do with physics. So all they're doing is describing this epoch mathematically and what happens according to them inside the labs. At such and such temperatures, you create certain effects. And that's what they extrapolated to the beginning of the universe. Okay, so this is how they came up with all this stuff. Okay, at the end of this epoch, gravity split away from the superforce. The superforce is the four forces together. Okay, and so you have gravity in there, you have gluon in there, you have the weak force, and you have the electromagnetic force. They're all in this so-called super force. Okay, so we have super force in there. Gravity, the graviton, I guess, is going to fly away. This force is going to fly away. It doesn't make any sense to me. I mean, how do you say, well, I have push and pull together in a super force, and I'm going to pull or expel the pull force out of there? What sense does that possibly make? That you're going to expel or emit, get rid of the pull, one of the two forces in this case, right? The pull force, you're going to kick it out and you're going to stay only with another force in there. This is what they claim happened in the Planck era. They said they had four forces. One of them, in this case, gravitational force, was kicked out of the club. No longer belongs to the club. And now you have the other three forces. Keep in mind what forces you got in there. You have the strong force, okay, which is the gluon particle, no matter. You have the, because we're not in the matter age yet, you have the electromagnetic force, the photon, a particle, which is not matter, I guess. And you have the weak force, the W's and Z's, which are particles, which are also not matter. Okay, we have these three forces still in there. We kicked out the graviton, or the gravity force. Okay, what's next? We have the gut. Here it is, the gut, the grand unified theory, okay? And what is that? Well, grand unified has, or they're trying to get this equation that represents the grand unified theory, meaning you have the electromagnetic force, the weak force, and the strong force together. And what happens here, they're going to kick out the strong force. They're going to kick it out of the club. And by doing so, they kicked out the two pull forces. They kicked out gravity in the previous episode. Now they're going to kick out the remaining pull force, the gluon force, the strong force, okay? And so that's what this epoch deals with, the kicking out of this force. Anyway, you want to interpret kicking out a force, okay, if that makes any sense to you. And so out of the three forces, now we have two forces in there, which are the electromagnetic force and the weak force, the W's and Z's and the photon, okay, which are not particles, or which are particles, but which are not matter. Somehow you got to try to explain that, okay, or to yourself, okay. Okay, what's the next step? Well, now we got to separate these two forces, okay? So we got to separate the electromagnetic from the weak force, okay? And again, I don't know how to illustrate a force. I put it as a little bit of smoke there. I mean, I hope you don't hold it against me. I have no other way of knowing what a force looks like, okay? So if you know, please let me know, okay? Because I'm totally ignorant. I confess I'm totally ignorant in these matters. So I had to put some smoke, some different smoke between weak force and the electromagnetic force. Please forgive me. Okay? And yeah, this is when the electromagnetic force separates from the weak force, okay, in this stage. Now remember, all these are microseconds. You're talking about infinitesimal part of a second. That's how fast this was. Boop, boop, boop. You know, that's how it went. Didn't even give you time to breathe, and they were already separated. Okay, keep that in mind. It's a very swift process. And where did they get that? All these things, they got them from equations. They do these calculations from what they observe in the lab. And they say, look, at such and such temperature and at such and such speeds, this is what happens. And they interpret that as a separation of forces. They extrapolate this to the beginning of the universe, and they say, this is what must have happened, you know, 13.7 billion years ago, okay? So that's how they come up with all this stuff. It's all equations. It's got nothing to do with you trying to visualize how a force separates from another force. It's got to do with equations. They say at this temperature, this is what would have happened. Okay, so all calculations, nothing more than that. Okay, what's the next step? We have this step here. It's, what is it, the electroweak. And I know this is the one I just had. Hold on. Let me go with the next one here. Where is it? The quark one. Okay, so now we're in the quark age. What is a quark? Well, you have three quarks, and they form part of one of the members of the nucleus of the atom. Okay, so you have what are called nucleons. Okay, you have things like neutrons, you have things like protons, and each one of these is made of three quarks. In one case, two downs and one up, the other one two ups and one down. Not important at all. Okay, they have these three quarks that make up the atom, and this is the age when these quarks are made. Okay, so it says the universe is too hot and dense for subatomic particles to form. So all you have so far are just these quarks, and they're running around. Running around where? I suppose in space, because each quark is contoured by space. What is the backdrop to each one of those particles? That's what you got to ask. And the problem here is that space is made out of particles according to quantum mechanics. So we have particles inside particles. Particles inside the ether, as I said originally, okay? The space of quantum mechanics and the space of general relativity as well are made of particles. Okay, so you don't have absolutely nothing. What you have is a sandbox, as I call it. They don't see it as a sandbox. They like to see it as a beehive. All these little bees running around. I don't know. You figure it out if it's a sandbox or a beehive. Bunch of bees moving around. You would need for them to be live. Otherwise, you would think that they're talking about a sandbox. And if you have a sandbox, you don't have much motion there other than perhaps gravitational motion, whatever gravity is. Okay, so keep in mind all this stuff. They would not be able to explain a lot of this stuff because if they have a sandbox, you know, how does one particle push another one over and do something with it? Create pressure or whatever you want to call it. You cannot explain motion. And if you have beehives, well, the particles have to be alive, because a beehive, you know, a bunch of bees, I think they're alive. They're, you know, flapping their wings. Okay. Okay. What comes next? The Hadron Era or Hadron Era. Okay. And what happens here? This is also a little bit magical, so, you know, hold on to your seat here, okay? Hadron, the universe cools down a little bit, okay? This allows quarks to bind together and form protons and neutrons, okay? So we're going to form protons and neutrons simply because the temperature dropped, okay? And one of the problems here is that you're going to form like a nucleus of the atom, okay? And they're going to show how this ends up creating not hydrogen, which is the number one element. They're going to start with helium. They're going to form helium. But it's going to be a helium atom that does not have electrons. It just has the nucleus. Okay? So keep this in mind. They're going to form a helium atom, okay, which consists of 4 nucleons, in other words, 2 protons and 2 neutrons. Helium atom is not 1 and 1, it's 2 and 2. You would have to have 2 electrons to counterbalance the 2 positive protons, but there are no electrons. All you have is just 2 protons and 2 neutrons. Okay, and they call that, I guess, a helium atom, an ionized helium atom. Okay. Okay, so this is you got to keep all this stuff in mind, because there are a lot of things that are not explained by quantum mechanics and all this. They just say, well, this is what the equations show, and this is what the kind of temperatures you would need to create this result. That's how they handle this. Okay. Okay, here we have the next era, the lepton and nuclear. We'll put them together here. Lepton and nuclear epoch. Protons and neutrons are fused and form again a nucleus. They form, each one of these is a nucleon, and when they get together, they form the nucleus. Okay, and that's when the helium comes into being. I put the electrons in there so that they wouldn't look so bad, so ignorant. Because as far as I know, helium requires 2 electrons for it to be helium. Otherwise, all you have is 2 protons and 2 neutrons. Is that just that alone? Is that a helium atom? And you wonder also about, hold it, why doesn't hydrogen come first before helium? Because see, the explanation they have for how a star works, let me get this guy out of here. Here. The explanation they have for how helium is formed, they say it's formed in the sun, inside a star. And that's okay, I have no problem with that. In fact, I like that theory quite a bit. And they say you take 4, you have to have 4 hydrogen atoms, you smash them together, okay? And with those 4, you create a helium atom. Why? Because you have to have 4 nucleons, 2 protons and 2 neutrons, right? And because you have 2 protons, you only have 2 positive charges. You counterbalance that with 2 electrons, which are the 2 negative charges. Okay? So okay, in general terms, I think it's reasonable. The question is, why would God create, the God of quantum, create helium before he created hydrogen, if we're trying to figure out how hydrogen came into being, and from there eventually to stars, and then smash them into helium? Because you can understand how helium is formed in the stars once you have hydrogen. But these people started helium and worked their way towards hydrogen. It's like, you know, God invented helium before he invented hydrogen. So you figure that out. I mean, I think it was easier to form hydrogen than helium. All you need is 1 proton, 1 electron. You would think that's easier, right? Why would God take the trouble of forming helium before he formed hydrogen is beyond my understanding. Okay, what is a lepton, just in case here, because we're talking about leptons. And this also is a can of worms. I'm not going to go in detail over it, but I just want you to understand what we're dealing with here. Lepton is an elementary particle, okay, of half-integer spin half, okay, that does not undergo strong interactions. I don't know what they're talking about. What do you mean half spin? You know, when I spin the top, the whole top spins. And I guess if it spins halfway, you stop it or stop the movie, or it falls or whatever, and you say, well, that was a half spin. I mean, how else are you going to understand it? Or maybe it's half a top spinning full spin. I mean, I don't know. I don't know how to interpret a half spin. And the answer is that they never defined the word spin. They have no idea what it means in physical terms. Spin is not what spin means to a normal human being. When you spin a top, you say that's spinning. Everybody understands that. Everybody understands when you say the earth spins. Everybody understands that. Half spin, minus half, minus one spins. Nobody understands that at all. In fact, the people who propose it don't understand it. It's just a mathematical device, invention, concoction. They say, yeah, it's a half spin. So what do you mean by spin? They don't know. But whenever they want to explain like how a magnet attracts another, they insinuate that, you know, the electrons are spinning on both magnets, and that's why they attract, the two magnets attract each other, because the electrons are spinning like a top in both magnets. So they use these words. They invent the word spin, and they say, well, you know what I mean by spin, don't you? Yeah, I know what you mean by spin. Well, okay, that's how a magnet attracts another. What do you really mean by spin? Oh, we don't know. Especially when they come with half spin and minus one spins and zero spins. You know, I mean, what is a zero spin? So again, you can't picture this. You cannot visualize what they're talking about. All you can do is use the term that they invented, and they say, well, it's a mathematical contraption. And you got to go to university to understand what spin means. But when they want to give you the physical interpretation, they use spin as if it were the spinning of a top. So they have these dualities, which they get away with murder. Because when people don't understand math, they don't care about math. They want to know, you know, how a magnet attracts another. And the guy says, well, the electrons are spinning in the same way, and you're visualizing spin, what spin means to you, that the electrons are really spinning. You say, okay, I more or less understand that. But when you put them against the wall and you say, well, what do you really mean by spin? They don't know. They say, well, no, it's not the spin of a top. We have no idea. So This is the issue. The issue is they have no explanations whatsoever, but they use these words, okay? They use these words like positive and negative. What do you mean by positive and negative? Oh, we don't know. These are all mathematical terms. Has nothing at all whatsoever to do with physical interpretations, which is what the normal, average human being out there on the street wants to know, wants to understand, okay? And there's two main classes of leptons exist. Charged leptons, also known as electron-like leptons, and neutral leptons, better known as neutrinos, okay? So, yeah, this is what the leptons are, and you figure it out. These are just labels, names that they've invented. We have no idea what they're talking about. In fact, they can't draw a single electron. They say they filmed an electron. Swedes did a few years ago. They came on the news. You say, okay, what's an electron look like? They say, well, we filmed it. And then they can't tell you what an atom looks like. I mean, if you filmed an electron and you filmed or took an image of gluons holding quarks together, because what they have is they smash these nucleons, one against the other, ions against ions, and they look at the explosion and say that's a gluon, that's a quark. Okay, so here they have these traces of gluons and quarks. They have the width of the trace through the gas, meaning that they know what the diameter of that gluon is or of that quark, and that's inside a nucleon, which is inside the nucleus of the atom. And they can see these little particles, or they image them, and then you ask them, well, what does an atom look like, which is a monster compared to all these, and they say, oh, we don't know. They can't draw an atom. Because if they draw the planetary atom with a little ball, you know, made of 3 quarks, mediated by gluons, and they have this electron going around, you say, well, what keeps the electron bound to the nucleus? They can't answer that question. They can't tell you physically what keeps it bound to the nucleus. Why doesn't the electron fly away? Why doesn't it fall to the nucleus? So these are the questions they can't answer, and those are the questions you should harp upon. You should ask those questions to all these quantum mechanics who claim that they have a PhD and that they know a lot. Okay, tell me why the electron doesn't fly away, why doesn't it fall inside the nucleus? What physically prevents it from flying away? What physically prevents it from falling inside the nucleus? That's what they got to answer. And if they tell you field, you say field's not a physical object. Can't use the word field to explain that. Okay. Okay, what's the next era? Well, now we start with the matter area. Now we move fast forward thousands of years. Okay, so here it is. This is the first stage of the matter era, and it's the atomic, what is it, phase, or is it the epoch, the atomic epoch, okay? And the universe cools, okay, so it's all about cooling, I guess, because it spreads out and it's so cold out there. It's like, I guess, moving inside a refrigerator. I don't know. The universe cools, electrons attached to nuclei. For the first time, now we have the atoms. See, so far we had the helium atom, but it was without electrons. Now the electrons join the atom, okay? And form atoms, recombinations, okay? And the second element finally is formed. Hydrogen, which is the first element on the table of the elements. Helium being number 2, made of 4 hydrogen atoms essentially. Okay, what comes next? Well, again, we jump from thousands to millions of years now, okay? And we enter the galactic era, okay? Oh, wrong one already. Let me put this one down here before I lose it. Give me a second here. Okay, here it is. This is the galactic era. Okay, and so what do we have here? Well, the formation of galaxies. But the formation of galaxies is a little strange because it's strange because we have no stars. Okay, all we have is whatever. It's called gas. So they say these islands of gas, those are galaxies because they are starless galaxies, if you can imagine such a thing. So it's just some kind of cloud of gas that's floating over here, another one over there, and another one over there. These are, I guess, the proto-galaxies. They're going to become galaxies eventually. Okay? This is where stars are going to form according to their evolution of the universe, the chronology. Okay? And yeah, it's also because of cooling. And these are the seedlings of galaxies, these clouds of gas. Okay, so that's how you have to interpret this. And then we enter the final stage, which is the one I guess we live in today. Okay, and that's the stellar era or epoch. And what is this? Well, it's the formation of stars. And the formation of stars happens, again, you have these gases. They form this, what is known as the nebular hypothesis, where you have these spinning masses of gas, and they collapse gravitationally. They start spinning and collapsing until at some point it nucleates, and at some point even further it ignites because of the pressures of atom against atom. Okay. And at some point, that pressure creates heat, gravitational pressure, and at some point it ignites and suddenly you have radiation come out of there, which is what we receive from the sun. Okay, so this is the last phase. That's where we're at now. Is there going to be another phase after this? Maybe we covered what? We covered thousands of years, we covered millions of years, billions of years, I guess the trillions of years is the next stage, whatever that's going to be. Just fizzling out into nothingness. The future of humanity, I guess, is gone. Because all matter will simply fly away so much from each other that it turns into dust. That's, I guess, what you're supposed to imagine. That's the universe these people are proposing. That's the one they believe in. Okay? Okay, so let's look at the comparisons of quantum mechanics versus Christianity, religion, the Bible story. Are they that different? Or are they different at all? And here you see it, okay? In one case you have God is assumed to be eternal. God creates heaven and the earth, okay? And we have all these different days. They're all days, okay? You would think they're typical 24-hour days. There's no reason to think otherwise, that these represent millions of years or anything like that. And on the right-hand side, you see the differences. You see the Planck scale, that happened in so many zeros that we cannot even imagine that. Grand unified happens at minus 10 to the minus 43 seconds. Inflationary period, minus 36. Electroweak, minus 32. And quark and hadron goes all the way to minus 12, minus 6. Okay, so until you get to the lepton, you get to the first second. So that's how all this proceeded. That's how fast all this was. And when you want to get into the nuclear era, well, then you get above a minute and a half, and so on. Matter era, well, that's totally different. 50,000 years, 200 million years, 3 billion years. So it's a little different than what you see on the left. Okay, what's different is the timing. One is exponential, the other one is constant, or I would think it's constant, unless you want to interpret that, but I don't see why you would have to interpret the Bible. The Bible should be straightforward so that everybody interprets the same thing. So you should not have to interpret the Bible. Okay? But here you see these people and they say, well, the first few seconds and microseconds, everything happened very fast. Boop, 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 boop. And suddenly you get to this stage where you produce the quarks and you produce the hadrons. And then it takes thousands of years until you get the first atoms. And from there, well, you get the galaxies first, which again seems like counterintuitive. And then you get the stars. And in the case of atoms, again, you get the helium atom before you get the hydrogen atom. That's the chronology that these people have. And again, we have no idea where all this stuff came from. They say it's an unscientific question. Okay, so this is after so many calculations, so much math, so all these PhDs from every university on the planet. This is the scientific method that they follow has taken them to these conclusions. Okay, so the question is whether what they're following is a scientific method. If this scientific method that they follow led them to such nonsense to come up with this evolution of how forces converted into particles, loose particles into formalized or organized particles such as atoms, and eventually into stars and galaxies, or galaxies and stars, I guess the other way around. Okay, so this is it. It's all magic, essentially. The method of mathemagics, I call it, or the mathemagical method. We have equations, observations, no definitions for any word, okay, important. They have experiment, they have predictions. What's the result of all this? Creation of something from nothing. That's the first one. And then we have this nonsensical, surrealistic, unexplained process of formation of matter. That's what we have today. That's what we ended up with after thousands of years of doing math, experiments, predictions, etc., etc., etc. So the question is whether they're following the right scientific method. Maybe they're following false gods. Okay, maybe that's what this is all about, following false gods. You got to make sure you follow the right God if you want to have eternal life or whatever. Okay, what do we do in real science? In science, let's put it side by side so we can compare these. Okay, this is how we do it in science. We have to define our terminology so that we have one idea of what we're talking about. And the first thing we have to define is something, and then we have to define nothing. And something is the opposite of nothing. They are antonyms. And so they have to be defined in such a way as you keep them that way. That way you can use them consistently and you can talk about whether something came from nothing and whether you can convert something into nothing. And so we say something is that which has shape and nothing that which doesn't have shape. See how easy it was all these years? And so space is a synonym of nothing, and so is vacuum. And something is anything that has shape. Okay, that which has shape. So we have something, that which has shape, nothing, that which doesn't have shape. Now we can use them consistently, and we cannot imagine a mechanism where you convert something into nothing or vice versa, taking nothing and converting it into something, with or without God, eternal or in any other way. You cannot imagine creating something from nothing, meaning that nothing suddenly acquired length, width, and height, and from one frame of the movie to the next one, in other words, in 0 time, suddenly something pops into being from nothing. That's known as magic. Not even God can do that kind of magic, okay? And so anyone proposing creationism in any way, shape, or form, especially under the guise of science, needs to explain the mechanism, and afterwards check himself into the nearest psychiatric ward. Okay? That's the conclusion we should reach. Okay, so let's compare what these people have versus what we propose. Okay, here's the quantum version, which is essentially the ether. If I can get this thing up there. Give me a second here. There he goes. That's quantum mechanics. That's the universe of quantum mechanics. Particles flying around. Okay, and the question is, what's the black stuff? Okay, if you say space, well, you can't say space because the white stuff is space. Space is made of particles in mathematical physics. So the particles that you see there moving around, that's space. You got to tell me what the black stuff is that gives shape to each one of these particles. The other one is, why are they moving? I mean, it should be a sandbox. And what you see here is a bunch of bees flying around, okay, moving, and for them they would have to be alive, okay, flapping their wings or whatever. So there's a lot of questions in the version of quantum mechanics. What do we propose instead? We propose that matter was not created. We're saying that matter was always there. It's eternal. Our universe, I hate to use the word universe, matter was eternal, and this is what it looks like. Here you get an idea. If we can get this thing here, okay, it's a single thread universe. There's a single thread, okay, it's a closed loop thread, and it's going to turn into the rope. Rope is going to go all around the universe, going to nucleate into what we call atoms, and then all these atoms are going to be tied or bound to each other by what we call the electromagnetic rope. That's all we have in the universe. That's how simple our universe is. No creation necessary. It's just a single thread that weaves all around the universe. Okay? And it never happened. It never, as far as I'm concerned, I cannot imagine how the single thread morphed through a process into atoms and ropes. It's always been like that. There was no moment of creation. Matter is eternal because we cannot imagine atoms turning into space, into empty space, or empty space, that which doesn't have shape, suddenly acquiring shape and turning into the thread, or atoms, or the ropes. So no, it's always been like that. It's always going to be like that when we're gone. Okay, you're going to have all these islands, galaxies, and they're going to have stars, and within those stars you're going to have planets. Within those planets, or near there, you're going to have asteroids and gases and so on. All of this is going to be made of atoms. All these atoms are going to be connected by the ropes that interconnect any two atoms. And the whole entire unit, all that matter is connected to the matter in another galaxy as well, which is connected to the other one, to connect the one into the other one. The entire matter in the universe is interconnected. Did it come into being? Did the rope somehow form atoms? Or did the thread form ropes? No. It's always been like that. And that's what people have trouble. They have no trouble imagining God being eternal. They say, okay, God's eternal. He had no mother, no umbilical cord. But when you say, well, the thread's eternal too. It's been there in the form that we see today. There's been no change. It's always been galaxies. And maybe the galaxies change a little bit here and there, and maybe they collide and form new galaxies or break apart. That probably more than likely happened. But other than that, all you have is just atoms forming parts of matter, and that matter being stars and galaxies and planets and whatever. That's our universe. It's always been like that. It's always going to be like that. Okay? So, in a nutshell, that is the universe we propose, and we propose it against what quantum mechanics proposes, which is all surrealistic, unimaginable. And if you come with general relativity, you know, with the black holes and dark matter and dark energy and Big Bang, well, then it's a total mess. So you figure it out. And again, here we're not here to convince you, because that's not our purpose. We're here to propose two universes. Okay, it's up to you to choose whichever one appeals better to you. The important thing is to understand it, to understand what the differences are and what the criticism are against mathematical physics. And with that, I'm going to go into questions and comments. Okay, so let's see what people had to say. And we had a lot of questions related to, especially what an object is, whether a square, people don't know what a square is still, whether a square is an object, a thing. And lots of questions there, and people still are fighting with that issue. So let's start at the beginning. And here I like to start with the golden principle. Okay, golden principle of physics. Okay, and I'm saying this is a non-negotiable principle. Rational people should not negotiate this one and agree or disagree or anything along those lines. This is it. You take it or leave it. Otherwise, you're an irrational individual. Okay, and here it is, the way I look at it. The golden principle. There it is. You can't do physics without an object. Physics requires an object. What would there be? What would be happening? What would there be to study? What would there be to analyze if there's nothing in the universe? No object, nothing. If you have total empty space or whatever you imagine, no shape whatsoever. What is moving? So no, you absolutely need an object to do physics. That's the first issue. So first you got to define the word object for the purposes of physics, and we define it as that which has shape. Now you know what an object is for the purposes of physics, that which has shape. Okay, and those are the synonyms there. And I like to say my greatest contribution to science, the definition of the word object destroys all religions. All religions die in the definition of the word object. Okay, and we're going to see that in a second here. We're going to see how a lot of religions go down the drain just with that definition. Okay, all we had to do was define that word object, so critical to physics. You can't do physics without an object, therefore you have to define the word object. What does it mean? What does that word mean for the purposes of physics? Okay, so now that we know what it means, that which has shape, it's not that which you can touch, it's not that which you can see, it's not that which exists, it's that which has shape. Okay, and I know people have not listened to what I just said, because they're going to go back to exist, they're going to go back to touch, they're going to go back to see, which are the criteria we use in ordinary speech and mathematical physics. Everybody has this idea that it's what you can touch or see. No, in physics, it's that which has shape. And I tell you, it takes 2 years for people to for that to sink into people's minds, okay? So I'm going to harp on that so much it's going to hurt. No, it's that which has shape, not that which exists, not that which you can touch, not that which you can see, okay? And I'm going to harp on that, and it's going to hurt, okay? It's going to make you lose your religion. Whatever religion you have, you're going to lose it right there in that definition. Okay, let's find out how these people begin to lose their religion. Losing my religion. Okay, here it is. First guy, he says, Bill's definition of object, that which has shape, is too simplistic. Well, I'm sorry it's so simple and it's been so easy all these years. In fact, good definitions are the simplest ones, especially when you're defining the foundations. The simplest or most basic words, they have to be as simple as possible. So I'm sorry it's too simple for you. Maybe it's below your mental state and you're flying in the clouds up there. Yeah, it is simplistic. I'm sorry. I'm sorry it was so easy, so kindergartenish. Okay, let's go with the second one. Along the same lines, all these folks. Okay, one fellow says the following. He says, to define an object that exists, you need at least 3 objects. An object cannot exist standalone. And again, failed to understand that completely. But the argument is that until he defines what an object is or what the word exist means, we have no idea what he's talking about. You need to define those two words in physics, because physics is the science of existence, among of objects and of existence. Consequently, I don't know if it's the same fellow. These are perhaps different fellows. I don't remember now. Consequently, objects of 0D, 1D, 2D, 4D, 11D, 2D, 3D, etc. are not really objects, but concepts, and cannot exist. And you can see they always go back to the word exist. They think that an object is that which exists. And they talk about concepts, but they have to define the word concept. Before they can do that, they have to define the word object and exist. And it says, dimensions each of the measures that determine the extent of an object, length, width, and height, or depth, wrong again, of an object as such has always and only 3D. Again, these people, first of all, they mix depth with height. No, depth is a vector. Depth is not a dimension. Okay, and if you don't understand that, well, you got a long ways to go. First, you got to understand the difference between vectors, dimensions, and coordinates. Okay, that's the first issue. But the issue here is that, there talks about dimensions of an object. And what does he go into again? 3D. Why? Because he's talking about exist. It's like you need the word exist to talk in physics. And they always go back to the word object and the word exist. So you can't live without those two words in physics. But but they confuse the word object with the word exist. They think they're synonyms. And so immediately when you say object, you say, a square has shape. Therefore, by definition, under rational science, is an object. They say, no, because it doesn't exist. No, I know it doesn't exist because a square is an object that doesn't exist. Exist has nothing to do with the word object, with the definition of the word object. And this is the whole issue. The issue, they keep going back to exist. And until they define the word object and the word exist, we have no idea what they're talking about. They're just running around in circles, chasing their tails, which is what all these so-called philosophers like Hume and Kant did for hundreds of years. Okay, here's another fella along the same lines, says what? Talking about angels. The image of the angel on a white background is not an object. Well, it's got shape, and why isn't it an object? The object called angel does not exist. Again, goes back to the word exist. It is not real. It is a concept. You see how they chase their tails around? They keep going around in circles. Why? Because they never define the word object and the word exist. You need to tell me what the word object means before you even mention the word in any sentence. And if you cannot define the word object, keep your mouth shut, because you have nothing to offer. All you're doing is chasing your tail around in circles. You're saying that an angel's not an object or a square is not an object because it doesn't exist. Exist has nothing to do with the definition of the word object, unless you can somehow define it in such a way that you embody it within the definition, in a specification. Okay, so again, these people are just chasing their tail around. They don't understand what the argument is, and they just go around in circles forever and ever and ever and ever. Okay, so here's a circular argument. Here's what the problem is with all these folks. The reasoning of the unreasonable. Object that which you can touch or see. That's what they think. They're thinking touch, see. And then they say exist, that which you can touch and see. Because what does exist? Well, what I can touch and see. That's what they think. And so they essentially have equated exist with object and object with exist. They think these two words are synonyms, which is the problem that we had with David Hume and Immanuel Kant. They also confused one with the other. Wittgenstein, Russell, Ayn Rand, Sartre, they all made the same error. They confused exist with object, with entity, with thing, with medium. They thought they were synonyms because they always thought that or proposed that an object is that which you can touch or see, exist is that which you can touch and see, and so they're synonyms. That's her whole argument. Okay, and here you have an air. Is air an object? I mean, it's made out of atoms, right? So you would think that if anything made out of atoms, like real atoms, like the air in here, well, if it's made out of atoms, it's got to be an object because you can touch it at least, right? So, but they say no, air is not an object because I can't see it, I guess, and neither is water, even though you can see and touch it. But why aren't these objects according to them? Because they're malleable, because they keep changing from moment to moment, second to second through motion. You know, they move. They're not stable, so they're not objects. So again, we don't know what an object is in their minds. And so that's the circular reasoning. They say object is see touch. An object is 3D. That's what they're thinking. Exist is 3D. Exist is also what you can see and touch, therefore exist as an object. That's their circular reasoning. And they never get out of that circle. They never get out of that circle because they're using, first, undefined terms. They're using the notions of ordinary speech. And until you define these two words precisely and not move a single letter out of that definition, you don't have a case. So first, anyone who wants to try, who doesn't like the fact that my definition destroys his religion, define the word object, define the word exist before you do anything, before you even make a comment. If you don't have a definition that you can defend for the word object, for the word exist, you have no case. You can't even start the discussion because you have nothing to offer, okay? So that's it. Anyone who wants to work on the words object and exist, begin by defining them. And please don't go into the dictionary. You won't find the definition in the dictionary because no one has defined it in the last 3,000 years. No one. No one knew what an object is. There's not a single book of physics that begins by defining the word object. And physics cannot be done without an object. And there's not a single book of physics on planet Earth, no textbook, no treatise, none of those that tell you what the word exist means. And physics is the science of existence. Physics explains or tries to figure out what exists out there in the invisible, intangible world of Mother Nature. So you need to define those two words, object and exist, thing and exist. Okay, and until you can define them, you have no case. Okay, another issue here, along the same lines, all these people in the same boat essentially, okay. Fellow says physics definition of object. Oh, the physics definition, oh, let's hear it. I want to see this. Identifiable collection of matter, which may be constrained by an identifiable boundary and may move as a unit by translation or blah, 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 blah in three-dimensional space. Okay, what's the problem with it? Well, first of all, he's proposing that this is part of physics, part of science. He says he got it out of a science book. Well, I doubt it because, see, when you look it up, we find out where he got this at. And it's no scientific book because there's no scientific book on planet Earth that defines the word object. That's why he's lying. He's lying out of every corner of his mouth. Now, here it is. When you look it up, you find out where he got this from. He got it from the Wikipedia. Okay, and he got it from an ordinary dictionary, the Oxford Dictionary, perhaps. It says, in common usage, not in science, in common usage, a physical object. Let me put it side by side so you can see that it's the same definition he put up there. Okay, here it is. In common usage, a physical object or physical body or simply an object or body is a collection of matter within a defined continuous boundary in three-dimensional space. So where did he get that? He got it not from a scientific dictionary, he got it from the Wikipedia. And it turns out that the Wikipedia has a little note there saying this article does not cite any sources. Please help improve this article by adding citations to reliable sources. Unsourced material may be challenged and removed. Of course, you're not going to find any reliable source for the word object, and certainly you won't find it in any science dictionary or book of physics. They never define the word object, and you can't do physics without an object. That's how simple it is. That destroys all of mathematical physics because it tells you that these people are just doing equations. They're not doing explanations of mechanisms. Okay? Okay, and then dictionary.com, you find object, anything that is visible or tangible. Again, anything is a synonym of object, so they're already starting with a synonym. And then they say visible or tangible, for which in both cases you need another object. So you need an object to define the word object. Great. And the same thing for the Oxford Dictionary. It says a material thing. Material is already an object, and thing is also a synonym of object. That can be seen or touched. Same thing, you need another object to see or touch. So all these definitions are irrational. They are synonyms. And when you use a synonym to define a word, that's no definition at all. All you have is a circular so-called definition, meaning no definition at all. Okay. Okay. Here's another comment on that that I put up there. Okay. Again, dictionary.com, they use the word anything and the word thing. Okay. And again, they have these loose definitions, like in the second case there, to which a person or matter to which thought or action is directed. Okay. And no, that's not an object for the purposes of science or of physics. Okay. Thing observed, who does the observing? Another thing. Anything that we can think of or talk about, that's the subject of a sentence. That's not a thing like a table. Okay, we can talk about motion. We can talk about orbit. Does that make orbit a thing? No, not in physics. Orbit is a verb, not a noun. Okay, for the purposes of physics, and so on down the line. Okay, entity and so on. They're all these are synonyms, and again, they have the wrong definition or the irrational definition because they equate it with that which you can see or touch, or that which exists, none of which are synonyms of the word object or define an object. Okay, I think it's the same fellow. He goes in there and continues, says, the physics definition of exist. Let me put it over here. And he says, the fact or state of living or having objective reality. Well, it turns out that when you look at reality, it's a synonym of exist. So we have a synonym again. And again, he's proposing that this is a scientific definition, and you will not find a definition of the word exist in any scientific dictionary. So again, he's trying to sell a whopper here. He's trying to say, I got this out of a scientific dictionary. No such monster, because that definition doesn't exist in any scientific dictionary. No one in the last 3,000 years in science and so-called science or mathematical physics has discovered that you need to define the word object and the word exist. Okay, and so when you look it up, this is what you find. Existence, the fact or state of living or having objective reality. Where did he get this? He got it from the Oxford Dictionary. That's where he got his definition, because that's where you find it. And the Oxford Dictionary is the normal dictionary of that everybody uses out there. What is reality? The state or quality of having existence. Okay, that's according to Oxford. Reality, according to Wikipedia, is the sum or aggregate of all that is real or existent. So what is reality? It's a synonym of exist, and you can't use the word reality to define the word exist. And then existence, the ontological property of being. What is being? Means the material or immaterial existence of a thing. Again, you can't use the word being, real, really, reality, any of those to define the word exist, because they are all synonyms. Okay, so anyone who uses those words does not have a definition. He's got a circular definition, and that definition is circular because they are using synonyms to try to define. So you got to define reality or exist or existence or real in such a way that you do not use the word being, any of those, that you do not use synonyms. That's the challenge for you. That's the $1 million challenge. Okay? If you can't do it, you got nothing to offer. You have your religion has been destroyed. Okay, so be aware. Okay, here we go. Another question, another comment. Fellow says, there is no physics definition. I think it's the same fellow. There is no physics definition of concept. No kidding. In physics, the standard definition is accepted. In other words, from ordinary speech, from the ordinary dictionary. What is a concept? When you look it up, an abstract idea, a general notion. And when you look at the word idea in the word notion, what do we find? Notion, conception, or idea of something. What is idea? Any conception, a thought, a conception, or notion. They're all synonyms. So we haven't learned anything about the word concept. We don't know what a concept is because they're using synonyms, idea, notion, to define the word concept. Okay? Oxford Dictionary, same thing. What is a concept? An abstract idea. What is abstract? Existing in thought or as an idea. What is an idea? A thought. What is a thought? An idea. We got it? So all we did was chase our tail around with all these definitions from magics, essentially, the so-called science. But I like this last comment that this guy made because it made me laugh. It really made my day. The guy says the following. He says, I will never be using your definitions. It's the kindest thing that anyone ever said to me, at least this week. He says, you destroyed all my religion. I can't find a single definition in the scientific dictionary, but I'm not going to use your definition, no matter what. Thank you. I really appreciate that. Okay, let's move on. Another question. Well, let me analyze that a little bit because here we have a little bit of authority or so-called authority from Ayn Rand. Okay, she's a gal that tried to attack this problem and she failed miserably. Okay, and so you ask her, what is something or what is exist? And she says, something exists which one perceives. No, we don't need to perceive anything. This has nothing to do with perception. But this is what Ayn Rand thought was something that exists. One exists possessing consciousness. No, we don't need consciousness to exist. A vegetable can exist. A person who's in a state of coma exists. And you can say there's no consciousness there. In fact, we can remove the brain completely, and for a few seconds that person is completely dead, and has no consciousness, but that person exists. That person is there. And you say, well, the body's there, not the consciousness. Well, what is consciousness? A concept. Do concepts exist? Do we have concepts floating out here? Or what is it? What do you mean by the consciousness exists? Or perception exists? Or any concept? How can you say that a concept exists like love? How can you say love exists? For this you have to define the word exist in such a way that it includes concepts. And that's what Ayn couldn't do, and she would never have been successful. Because you can't talk about the existence of any concept. Intelligence. You can't say intelligence exists, especially in the mathematical community. Now, you can't use concepts and say that they exist. You can only use the word exist in the context of objects. Okay? And so here are kind of responses to good old Ayn. Okay? And here it is. To exist is to be something, yeah, but that is not enough. In order to exist, you not only need to be something, but you must have location. That's the difference between what Ayn Rand did and what rationality is. You need location. It's got to be an object. It's got to have shape. And then in addition, you got to have location. And to exist requires a something. But to be something is not to exist. There are some things that don't exist. Neither perception nor consciousness have anything to do with existence or entities. Okay? Okay, and let's move on. With another comment that I want to make here, which is the key issue. Okay, here's the key issue. And it's that people, all these philosophers or so-called philosophers, why they failed. And I found a statement that summarizes where they all went wrong. And it's that they separate two kinds of existence. One is the existence with which we should be concerned here is not just any existent thing, but human existence. Okay, so that these people have separated human existence from the existence of a rock, for example. And what do we mean by human existence? Well, we're talking about consciousness, about thinking, about mind. Okay, that's where the problem comes in. There is thus an important difference between distinctively human existence and anything else. And human existence is not to be understood on the model of things, that is, as objects of knowledge. Okay? So these people are talking about perception, and they get confused with perception and thinking and mind and consciousness. That's where the problem comes in. Okay? Okay, here we have another comment. Okay. Mediator. One person says, what is a mediator? One that mediates. He defines it. He looks up for a definition. A mediating agent in a physical, chemical, or biological process. Okay. Yeah, again, the problem is when you look up these words in the ordinary dictionary, you're going to get irrational definitions. And that's where the people... You know, you shouldn't look at the dictionaries. You should look at your mind and say, what do we really mean by this word? How do we apply it in science? If you just get words from ordinary speech, you're going to get them all wrong because there are no scientific definitions out there. That's the problem. And so you can't just transcribe and say, oh, I found this at the dictionary. This is what it means. Well, does it make sense? Because if it doesn't make sense, I don't care where you got it. Okay, you got to try to make sense and be able to defend your definition, not just copy. Anybody can transcribe, copy. You know, what have you done? A lot of work, you know, no mental work. The word comes from mediate, la la la. Okay, is it light a mediator? Okay, light, remember I said it the other day, light, if you're talking about the rope, the electromagnetic rope that mediates, that serves as a mediator, we're talking about a physical object. But if you're talking about the torsion moving along the rope, then you're not talking about a physical object. So what is a mediator? Well, the mediator has to be an object. Mediator is a synonym of thing, of entity, of object. That's what a mediator is. We're talking about a physical entity, what? That which has shape. That's a mediator. Okay, so you can't say torsion is a mediator. No, torsion is the verb done by the mediator. Okay, that's the way you're supposed to interpret that. Okay, another issue, another common question. Here it is. See if we can get it up here. They're all far at the bottom. Okay, it says, by definition, nothing should have no dimension. That is, no surface, no volume. Your nothing, empty space, has no surface. Yeah, good. I like that. Shape, that could be observed. No, it's got nothing to do with observing. Okay, it's got nothing to do with observers, with what people think. It's got to do with definitions. That's what it is. But he says it's got no surface no surface or volume. Okay, I would show here that surface is all that your nothing has. Surface has nothing has surface. Oh, I want to see this. Where he got this? And yet it still magically retains volume. I don't know where he got this notion of volume. Volume is a mathematical concept, has nothing to do with what we're talking about here. But he says, you're nothing. Empty space is not shapeless after all. Oh, is it? Okay. It is filled by one-dimensional entities, ropes or strings, which give shape to this still volumeless empty space. I don't know how the fact that you got ropes inside space gives shape to space. So far we have shapes of the ropes, not of space. But he says nothing by your own definition of nothing, volume without shape. No, space has no volume. Volume, only physical objects have volume. Okay, and what does the volume mean? It means expansion. Okay, how much space it takes up, because they're assuming it's like the fish pushing out volume of water that it occupies. So volume is a dynamic concept, okay, and that's why it has a unit. Anything that's got units is always a dynamic concept, okay, in mathematics. So no, space does not have volume. Okay, so I don't know where he got that volume thingy. Okay, another common question. Here it is. Fellow says, you can't point to your shadow. He's asking now, yeah, you can't point to your shadow? I can point to mine all day long. No, you can't point to a shadow because shadow, the word shadow means blocked light. You can't point to block light because block light, there's no physical standalone object called block light. But there's another issue here, and that's where does the shadow start? Okay, here it is. Let me show you graphically what I'm talking about. Does the shadow stand alone, or does it touch all the way to his feet? Where does shadow begin? Because see, when you have an object like a ring, it's completely all around is the ring. But a shadow is tied to whatever object is blocking the light. That's why it's called block light. That's what a shadow is. That, in other words, that's what the word shadow means, block light. So where does a shadow start? Is it a standalone object? Is it completely, does it have shape? You say, well, it's got shape. See, I can point to it. No, you can't point to it because I don't know where it starts. As far as I'm concerned, you're pointing to the man, okay? Because the shadow comes out of his feet. If you're going to talk about the shadow, you talk about the man, no problem. Because here, like I show here, you can have the man without the shadow. And so let's show that. Okay, here you have the man without a shadow. Or you have the shadow only because you have a light there pointing at him. But we could have no light and there would be no shadow at all. So we don't need the shadow to have man, but we certainly need the man to have shadow. Okay, and the question is that shadow, even if the light is shown straight ahead and the guy's, above floating in space, the shadow extends all the way to his body. So the shadow really is not a shape in the sense that that you can find out where it starts. You have no idea where a shadow starts because it starts at the foot of the other guy. And here, let me show you this guy now in space to give you an idea here. Again, if you shine a light in space, his shadow starts at the man. Okay, there is no thing as a shadow that stands alone in the sense that you can say it's got shape because the shape extends all the way to man. You don't have a shape for blocked light. Blocked light goes all the way to the thing that's blocking the light. So if you can tell me where the shadow, whatever shadow, of a tree, of a plant, of a rock, where it starts, if you can tell me that, it'd be great. Show me that it's got shape all around, meaning standalone, that it doesn't require another object. That's the issue with shadow. Okay, another issue, another comment. Fellow says, you haven't given any definition of the word God. Can you give a definition of the word God? Well, I'm not proposing God. So it's the person who proposes God who's got to give the definition. He's got to tell you what he means by God. Whenever I use the word God, I usually refer to the Bible, to the Old Testament, and I use the God that God testified on his own behalf of who he is. He says, I have a face, I have eyes, I have a nose, I have ears. I covered that last week. And so God is made in our image, according to the Bible. And that's the God I use. So God is not a definition. I point to God, say that's God. And it's a bearded guy, I guess flying around in space. Maybe he's got a magic wand, I don't know. I don't have to define God because I don't propose God. And second, I don't define God, I point to him. Okay, I use the God of the Old Testament. Okay, here's one fellow who criticizes that to some degree. He says, Bill, thinking that the King James Version Bible is even close to an accurate translation of the Old Testament is laughable. Okay, what we have to think about here is that, the Bible has many translations. And the reason they have translated it so many times is not unknown. We know why they've translated the Bible so many times, okay? And why there are new versions every day of the Bible. And here, let me show you just for the sake of argument that in the past, They translated the Bible first into Latin, then they translated here for the first time into Spanish. Okay, this is the first European language into which the Bible was translated in the year 1280. Okay, it's known as the Alfonsina Bible. About 100 years later, they translated the Bible into German. Okay, Wenceslaw Bible. And so there's been different Bibles throughout time. The most famous, however, are the first one is the Casiodoro de Reina Bible in Spanish. This is really, you can say, the most famous Bible in Spanish, the one used in the Spanish world. In England, they came up with a Bible similar to that, and a few years later, about 60 years later, the King James Version, which is the one I use. And the reason I use it is because if you look at the Spanish version and you look at the English version, they match quite well. And since then, it's been modified. A lot of stuff have been modified. Among them, the clobber passages, which are in the process of being modified even today. And for those of you who are not familiar with those, they have to do with the gay passages in the Bible. There's about 7 of them, and they're known as the clobber passages because they clobber homosexuality. And a lot of people have problems with that, out there, not only homosexuals, but people who defend them. And they don't like that, and they're trying to reinterpret those passages. And so, yeah, they don't like those passages. And what they do, they create new Bibles that modify such passages. Not only those, there are other passages they're modifying out there. And so they're modifying these passages because everybody has a different interpretation first. And second, they don't like some of the things that the Bible says about what they believe. And so that's why they're changing these Bibles. And because they're changing them, I stick to what's been around for a while, first of all, and second, that matches the Spanish version with the English version, which is the King James Bible. They were a little more naive in those days. They just translated it directly. There was no need for cheating, for reinterpreting certain things that were straightforward. And today we're doing that. Why? Because a lot of people don't like what they read in the Bible. It destroys their religion. They say, no, I like the Bible, but let me reinterpret what the author wrote in there. And so that's why, I'm going to use the King James Version until I die. Okay, and I did read the Bible 3 times completely because it's a book I like. I read it when I was young. Read it 3 times, beginning to end, all the way. And so I know a little bit what's inside the Bible. And believe me, they've changed the Bible. And again, they changed the Bible because everybody wants to interpret a new religion. In fact, here you can see that religion has changed. Here's the God of the Old Testament, okay? It's just the God of the Old Testament, okay? And he was a God of punishment. There was no love in there. He just came in there and he would send plagues and whatever he could to punish people. People saw God's punishment as armies invading them. Genghis Khan and maybe Attila the Hun. They saw that as punishment from God. They say, God is going to punish us because we've been sinning. And when these troops came over and beat them up or left some people alive and said, you got to pay tribute, you're going to be our slaves, they said, God has punished us. It was all punishment. They would crucify people, burn them at the stake. They would threaten you with going to hell. It was all bad. You look at the Old Testament, it's like that. The New Testament is a little different. It's more like what we see today, okay? And here it is. This is the New Testament, okay? It's the God of love and diversity. That's what it's all about. It's a smiling God. And if you behave well, you have eternal life, and it's going to be a blissful life because God pardons everything. He doesn't punish. He's a God of love. And so he accepts everything. He wants brotherhood. And so we have a difference between the God of the Old Testament and the God of the New Testament. I always point that out. Among other things, that the God of the Old Testament is a physical God, whereas the God of the New Testament is an abstract God. It's a concept. And today we've become even more abstract with God. Today, again, you get people like Deepak Chopra. He says God is intelligence. And so if God is intelligence, how did intelligence, a concept, create the universe? And those are the questions they just skip over and say, well, let's not talk about that. Let's talk about behavior. Let's talk about consciousness. Let's talk about, you know, whether you're going to go to heaven, have eternity, life after death, or whatever. They want to talk about stuff like that. They don't want to talk about physics, how the universe came into being, which was the subject of today. And so, yeah, God has become ever more abstract. And that's why I try to go back to not only to the Old Testament, but also to the King James Version, because that one doesn't lie. And that one is very close to the one we have in Spanish, and I can match them almost identically. The Bibles of today, you can't do that anymore. Everybody's got their own Bible now, according to their own personal religion, and they want to shove that one down your throat. Everybody creates a new sect. That's what we have today. With that, I'll see you next time around, which is on Wednesday. We'll see you then. Bye-bye.